Yeah. So mean value theorem, what is the mathematical meaning of the word mean? Average. When have we used the word average in this class? Talking about average rate of change. That's your indicator of when to use mean value theorem, when you're talking about average rate of change and slope and all that. So look at the conditions for mean value theorem. F has to be continuous. Does that sound familiar? Should. Closed interval. Yep. Differentiable. This is new. Okay, the other theorems, F did not have to be differentiable, but to use mean value theorem, because we are talking about slope and the derivative, it has to be differentiable. So graphically, what are we not going to have?
No cusps.
Yeah, no cusps. Good. Okay. Then we get this formula. Okay, let's not worry about the formula yet. Let's skip down here and I'll come back to that. It says geometrically the theorem guarantees that there is an existence of a tangent line that is parallel to the secant line. If two lines are parallel, what is the deal with their slopes?
Same slope.
Same slope. So the slope of a tangent line is equal to the slope of the secant line. Okay, and this is what we're going to look at for today. What type of rate of change? Well, let me back up. We already said average rate of change is something we're going to talk about today. Average rate of change, does that have to do with tangent or secant?
Secant.
And let me remind you really quick that tangent has to do with 1 point and secant has to do with 2 points. So which one is average? Can you do average of 1? No, you can only do average of 2. So I'm going to put the average rate of change over here to the right, and I'm going to put AROC next to it. Remember, that was just the acronym for average rate of change. So what should go in the other blank? What's the other? Instantaneous rate of change. And this is where we start doing derivatives and things like that. Okay, and we called this IROC. So the very first day of school, we talked about these things. Okay, I didn't really even say mean value theorem, but I said a lot of these words. So again, I haven't gone up to the formula yet, but I want you to look at this picture. Okay, and let's draw the secant line from A to B. So first of all, this is continuous and differentiable on a closed interval, so I know that I can use this theorem. So there is my secant line. So the secant line connects those 2 points. Okay, the slope of this secant line is equal to rise over run. Okay, f of b minus f of a over b minus a. Basically, y minus y over x minus x, or however you want to think about it. That's how you do the secant line. It's just basic slope. That's why we need 2 points. And that is the average rate of change. Okay, now do you see a place on the curve that if we zoom in, so like for instance, watch what I'm going to do here. Don't write this on your paper yet. But if I zoom in right here, see how that looks like a line? And if I extended that line, okay, it doesn't have the same slope. They're not parallel. But do you see a place where that could happen? And it could be more than one. Anybody want to share? Next to the little F or A? What did you say? Wait, which did you say though? Okay. So maybe right about here?
Yeah.
All right, and if you kind of extend this slope out this way, that gives me a tangent line. Yes, do draw this. Thank you. That's a tangent line. This is the instantaneous rate of change. And the way I would figure out the slope is I would take the derivative of my function and I would plug in a value. And since we've already used a b, let's go ahead and use a c. So we kind of have 2 categories here. And if I zoom up a little bit, or scroll up, that's what this formula says. Okay? It's just setting these two things equal to each other. So we'll use that in a minute. But all right, was anybody thinking that there was another place on the graph that also could produce a tangent line? There's one. Yeah, right about here maybe. So there is at least one. There could be more than one. There won't be a lot though. So a green dot is just another possibility for a C. So mean value theorem says that there has to be at least one place, could be, like in this case, two places, where if you draw the tangent line, it is parallel to the secant line. Mathematically or algebraically, it's where the derivative is equal to the average rate of change. So before we practice the algebra of this, I want to go through one more picture. So go ahead, read example 2, and go ahead and do what it says and answer the question that it says. Okay, so hopefully your graph should look something like that. Okay, and what theorem was shown by this? MVT. Now that's super easy when this is the theorem we're talking about today. So a month from now, if I give you this problem again, how are you going to know that it's mean value theorem instead of extreme or intermediate? Parallel lines, that's the biggest indicator here. One of these represented average rate of change, which is what mean means, mean value theorem. Do you see any other trio of points on this graph that would work out the same way, where if you connected two of them and then did the tangent for the middle one, B and D?
Oh wait.
Yeah, there's more than one. Yeah, it works a lot. And so, it doesn't always have to happen, like where they place the points, but this is a graph where it happens a lot of the places. Okay, let's move on to the next page. Okay, we're just going to go through a few examples and then we'll finish this up on Monday. So, your homework is really tonight, okay, which isn't even due Monday, is going to be mostly focused on the concept of mean value theorem. But what we're going to do now is actually practice it. So they give you the formula here, and they say apply mean value theorem. It is good to go ahead and make sure that f is continuous and differentiable. Okay, and so and we have a closed interval. So let's go ahead on the picture and put in our endpoints at 1 and 4. This is like your A and your B. So between these 2 points, is the function continuous? Yes. Is it differentiable? Yeah. There's no cusps or anything. Okay. You can see, you may say, well, that's always going to happen. Well, if my interval was -1 to 4, I would have an issue because I cannot plug 0 in for x. So it will work out though. Like when it says apply the mean value theorem, these things are going to be okay. All right, so what we need to do is we need to take the derivative to figure out what the IROC is, and then we need to evaluate AROC, and we need to set them equal to each other. Okay, you can do this in either order. I think maybe finding derivative is probably first step most people will do, because that's what we do in a lot of problems. So if I'm going to derive this, what's something I could do to the x to maybe make this a little bit easier? Yeah. And so when I derive that, go ahead and derive it. Okay, I got 4x to the -2. If you have a negative in front, it's just you forgot the whole negative times a negative is a positive. And I rewrote it as 4 over x squared because I'm about to set this thing equal to a fraction. And so it's going to only help me if my derivative is a fraction. Okay, so now let's do the AROC piece. So this is going to be f of 4 minus f of 1 over 4 minus 1. So you could either plug in 4 or 1 into the original, or you could actually use rise over run since we're given a graph. So it looks like up 3 over 3. If you were to actually plug this in, your work would look like this. So what we want to do next is set that derivative equal to our average rate of change. And I'm going to go ahead and put it as 1 over 1 so that we can cross multiply. And so what does x equal? 2. Anybody thinking plus minus 2? Technically that is, but why do we not really care about the negative 2? Yeah, it's not in my interval, so it's not going to be my answer. So x equals 2 is fine. C equals 2 is a little bit better because it did say find all values of C. Now, if you wrote x equals 2, I'm not going to take off for that, and the AP test won't either. It's okay. So let's see. Okay, well, what did we actually find? Okay, look at where x equals 2 and find that point on the graph. And draw the tangent line. See how those two lines are parallel? So before we were kind of just drawing it. Here we were actually finding where that it was true. Do you think you could have more than one value of C in a given problem?
Yes.
Yes. It was like in that very first example we looked at. All right. So that was a pretty standard example. Okay, definitely going to see stuff like that. Example 4 kind of starts us into some word problems. So we've kind of been talking more theory. Let's bring it back down to reality. Example 4 says a plane begins its takeoff at 2 on a 2,500 mile flight. The plane arrives at 7:30. Explain why there must be at least 2 times during the flight when the speed is 400 miles per hour. So without using calculus, I want you to internalize this. Think about why this makes sense. Okay, what happens to a plane's speed as it goes on its trip? It starts at 0. It increases to some cruising speed, probably some fluctuation, and then eventually the speed decreases back down to 0. And there's some maximum speed. Now, you don't have to know about planes. Have any of you, though, on a flight ever, like, clicked on that screen where it shows you the plane? Like, especially if you take, like, a transatlantic flight, it's kind of interesting to be, like, all over water. And it tells you, like, how fast the plane is going. And so planes go pretty dang fast, right? They have to, or it would take forever to get anywhere. But why does the speed have to be 400? Like, how do I know if I'm even going to reach 400 miles per hour? Like, what else in the problem could we use? And I'm not interested in calculus here, just... Okay, so if we're going 2,500 miles, how much time did that take? 5.5 hours. So this gets you like 464 or 454 point something. Okay, not really concerned about that part, but it's over 400. This is our average speed. Okay, the average speed is 454 miles per hour. So how do I know then that the plane has to have an exact speed of 400 miles per hour at least twice? Yeah, it has to go through 400 to get to 454. This is actually a little bit of you could prove this if you needed to prove it using intermediate value theorem. You could also prove it using mean value theorem. Just using the fact that the average speed has to equal the exact speed. Okay, and in this case, it's really more like the average speed and everything less than the average speed has to equal exact speed at least twice. Okay, so this kind of just is not so much a problem as it is just a way to connect like the common sense application of what this theorem means. Okay, go ahead and look on the next page. This is the last problem we're going to do today. So this is another word problem. Company introduces a new product, units sold. So that's up here. This is like S of t. And t over here is the time, and that's in months. And they give us this weird equation, but it's given to us, and the graph is given to us. And part A says find the average rate of change, AROC, during the first year. So what's my interval? 0 to 12. Okay. We can go ahead and block it off like how we did on the other pictures. What this is really asking us is, what is this slope? So we could use rise over run. This up here is not a pretty point. So this is where maybe doing S of 12 minus S of 0 is a little bit more useful. And you would definitely want to use your calculator here. So go ahead and get your calculator out, or you can use the one on your phone. You want to plug 12 in, and then you want to plug 0 in to this original. This is not talking about derivative here. This is average rate of change. For those of you that don't have a calculator, I just really want to make sure, or for everybody, I really want to make sure you understand what we're doing here. And if this were all we were doing, we could leave our answer just like this, right? Just put an MPH at the end and be done with it. But because there's a next step, we need to simplify this. Now, when you're actually simplifying this, you could get a fraction or you could get a decimal. Which one makes more sense if you were like doing this to report to your boss? Maybe a decimal, maybe a fraction. It kind of depends. But if we use a decimal, we're probably going to have to round, so it won't be accurate. So let's go ahead and keep our answer as a fraction. And just because it's Friday, I'm going to give you that one. So 450 over 7. Why'd I write MPH? I'm stuck on speed from that other problem. So this would be units per what? Per month. So this is why I was saying maybe a fraction would maybe even be better, because it's like 450 units per 7 months. It kind of just depends on what you're using it for. Now what we're going to do is answer this question. During what month does S prime equal the average during the first year? So we got to find S prime. So let's come back up here. And before we find S prime, let's do ourselves a favor and distribute. So 1,000 minus 1,800 over 2 plus t. And I can even do something else, because if I'm going to take derivative of this, what rule do I have to use as it is right now? Quotient, which isn't horrible, but because the numerator is just a number, I can actually rewrite it like this. 2 plus t to the negative 1. Okay, and that's not the derivative, so let me scroll up just enough. But this helps us find the derivative. So derivative of 1,000, that's 0. Negative 1 times negative 1,800. It's positive 1,800. Keep the 2 plus t alone, same I mean, and then subtract 1. And then technically you would want to multiply by the derivative of the inside, which happens to be 1. And then we're going to rewrite this so it's a little bit easier to work with. So the times 1 doesn't really matter. But watch what I'm going to do here. I'm going to move that 2 plus t back down to the denominator. This is why we kind of practice some of that simplifying, because here it's just going to help us. Because my next step is saying, when does S prime equal 450 over 7? So having this written in this manner helps me. It makes the next step easier. Okay, any ideas on how we could solve this? Okay, with the calculator, what would be the easiest way to do it? Solve feature. Okay, but definitely we can cross multiply. That's a lot of parentheses if we wanted to use the solve feature. So maybe doing something like this might actually be easier. If you happen to not have your calculator, you could probably simplify this enough to figure it out. I'm going to go ahead and give it to you again. It's my Friday gift. That right side ends up being 28. So what is just 2 plus t equal to? Square root of 28. Am I going to bother with negative square root of 28? No, because if I do square root of 28, the negative version of it, and subtract 2, I'm going to have a negative answer. And that's a problem because we're not going to have negative time. So t exactly equals root 28 minus 2. What this ends up being, though, as a decimal, I'm going to cheat here in a minute, or right now, is 3.292 months. Those 2's got a little weird. Let me rewrite them. So we're almost done. We're not quite, because we didn't really answer the question. If the question had been, what is the value of t when this happens, we're good. But it says during which month? So how do we answer this?
April.
Okay, that's one way. That is one way to answer it. So I'm going to say, let's say during the first month. You know what I mean? Like, so which month is it?
April. But also, like, all months are different. So, I mean,
You're right. We don't know that we're really starting on January 1. And you're right with the days. So that's what I'm saying. Don't give me the name of a month. Like,
During the third month.
is it during the first month?
During the fourth.
Like, right? It's not. So my question really, and y'all's two said it, is it during the third month or the fourth month?
it's more than
It's during the fourth.
It's during the fourth.
Fourth.
For those of you that are like, what? Think of it this way. You guys are seniors. How long have you been in high school?
2 months.
No, think of, like, how many years have you been in high school?
3.
3 years and some change. 3 and some change. Are you in your 3rd year of high school or your 4th year? Got it? Okay, now if we go back up to the picture, it kind of makes a little bit more sense. First of all, we can kind of make sure these two lines are parallel. But secondly, we could say first month, second month, third month, fourth month. Okay? It's an interesting way of putting that question, but we got to make sure we answer the question they're asking.